terms and pieces of information we need to get through before we can do anything more advanced about circuits. A few terms we need to define and things of that nature. So current is basically just moving charge. When we talk about current going through a circuit, that means there's some kind of charge moving. Typically, in normal electronics, the wires are metal, and so what is moving is actually electrons are moving. Although in other cases it might be something else, like in voltaic cells, I think you can have different ions that move, but most commonly and in most electronic devices, it is electrons that are moving as they flow through a wire made of copper or some other conducting metal. Now, despite the fact that it is electrons moving, the same thing happens in circuits as if, so let's say we've got a circuit, and electrons are going this way. They're moving around. They're moving around the circuit. This functions exactly the same way as if positive charges were moving the other direction. So even though electrons are actually what moves, it's a lot of things can be easier to wrap your mind around. There are just less double negatives when you're thinking through math. If you consider it, generally, and we do it this way, generally we say that current flows in the direction of positive charge. Is moving. So even though in a circuit what's really happening is that electrons would be going this direction, we conceive of it as positive charges moving the other way. Mathematically, we'll get the same results because negative going one way is kind of the same as a positive going the other way. We'll get the same results, and it's easier to think about with positive charges moving. So that's what we generally do. Although you should keep in mind and know that it is usually electrons that are moving. Current, the variable for current is I, and it's equal to a charge per time. The unit, therefore, is a coulomb per second, and 1 coulomb per second is an ampere, which is a capital A. It was named after a guy named Ampere. And the ampere, for reasons that I cannot fathom, is considered a fundamental SI unit. I'm not really sure why they decided to make current, make current the fundamental quantity. It makes more sense to me to make charge the fundamental quantity, coulombs, but in SI, amperes are defined to be the fundamental unit. That is what it is, and we'll accept it. Some more terms. A circuit, which I used the term already, but didn't really define it. A circuit is a system where charge moves along a closed path. Basically, all electronic devices are circuits of some level of complexity or another. Light bulbs run off of a circuit where there's just current flowing through the wire, it's different with fluorescent light bulbs, which you see more often now, but the old filament light bulbs, there would just be charge that runs through, and that charge running through generates heat and light in the light bulb filament. And there are two types of current that can flow in circuits. There's DC, which stands for direct current, not District of Columbia, at least not here, where there's constant current in a direction, and then there is also alternating current, which means that the current alternates direction. And we will talk more about alternating current in another chapter. So this DC is what we'll be dealing with throughout this chapter. Alternating current has a lot to do with the way that electricity is related to magnetism. So we'll wind up hitting that later. A battery. You guys all know what a battery is, or you've seen a battery, but you may not have thought about what it is physics-wise. What the battery does is it creates a potential difference between its two terminals. And this is done typically via some kind of chemical reaction. And that chemical reaction creates the potential difference. And because there is a potential difference, electrons tend to flow from the negative terminal toward the positive terminal. Terminal is just the two ends of the battery. So a typical battery looks like this, and it has a little nub on the end there, which isn't quite that big. But this is the negative side, the positive side, and so because of that, there's a potential difference. The electrons, are free to flow, and they flow from the negative side toward the positive side. Some batteries, like car batteries or just 9-volt batteries, have two little things on top, and one of those is a positive terminal, and one of those is the negative terminal. So it depends on how the battery's structured, what that looks like exactly. A switch. You guys have all flipped a light switch before, but a switch is something that is opened or closed to prevent or allow current to flow. Right? And so, what's happening when you flip a light switch? When you turn it on, you're closing the switch so that the circuit is complete. Whereas if you flip it off, you're opening the switch. Batteries, I'll start introducing this. Batteries in a circuit diagram are two parallel lines, one of which is smaller than the other. The larger side represents the positive terminal, the smaller line represents the negative terminal. So this is our battery hooked up to some kind of circuit. There might be other stuff over here. We'll have symbols for resistors and capacitors and those sorts of things that can go in circuits, but that's what a battery looks like. A switch will look like this. It's diagrammed like this. So there's some piece here that can, when it's open, then there's just air between these two pieces of wire, and the current won't flow. But then if it's closed, it can swing down to close, and then there will be current to flow, and then there will be other, whatever other circuit elements might be there. Right. Another term that is kind of unaptly named is what's called the electromotive force. And I say it's unaptly named because it's not a force. So I'm going to put quotes around force. It's not actually a force. I don't really, initially it was called a force, way back in the day, and then they figured out it wasn't a force, but we still call it the electromotive force, which I think is kind of dumb because it's confusing, but it is what it is. That's abbreviated EMF, and the EMF, which is epsilon, not to be confused with epsilon naught, which is permittivity of free space, is just the potential difference between the terminals of the battery. So we'll be using this little symbol this little epsilon to represent the potential difference between the terminals of the battery as we go along. An interesting fact in circuits is that you know that when you flip the switch, the light goes on basically instantly. Well, the electrons in the circuit actually have a relatively small velocity. But they domino. So, you know, one electron moves, you got your wire, one electron moves a little bit, and then that causes this next electron to move, and that causes this next electron to move because they repel each other. And so even though any individual electron has a relatively small velocity, current propagates at close to the speed of light. So there's no physical object moving that fast. An individual electron is only moving a small amount, but because they're all moving a small amount and having this domino effect, then current does flow at close to the speed of light. So that's why when you flip a light switch on or off, it basically turns on or off pretty much instantly, depending on the kind of light it is. A filament light bulb would turn on basically instantly. The fluorescent ones kind of like flicker and flash, but they start turning on instantly, even though nothing in the circuit is actually moving at a really fast speed.